Imagine a gas, like a literal gas that essentially dictates how long you live.
Right, and it controls your blood pressure, your physical stamina. I mean, pretty much all of it.
Yeah, and it's so important it even won a Nobel Prize. But here is the catch. It vanishes in a fraction of a second.
Just poof, gone in milliseconds.
Exactly. You can't store it in a tank. You can't just go buy it in a pill.
No, you definitely can't. To manufacture it, your body actually relies almost entirely on this invisible colony of microscopic bugs.
Bugs living right on the very back of your tongue. I mean, welcome to today's deep dive because it sounds completely like science fiction.
It really does sound made up, doesn't it? Like a biological system that delicate.
Yeah, and utterly dependent on outside forces. We always think of our cardiovascular system as this, rigid plumbing.
Right, like a heavy-duty pump pushing fluid through these static rubber hoses.
But the reality is your blood vessels are constantly shifting. They're expanding and reacting to this one microscopic, incredibly fragile puff of gas.
Which is wild when you think about how much relies on it.
It's mind-blowing. So, for you listening, our mission today is to uncover exactly how this tiny, fleeting molecule operates inside you. We are diving into this super comprehensive article from My Whole Foods by Gregory David.
Yeah, it's called Nitric Oxide, How Whole Foods Supercharge Your Vascular System.
Right. And we want to look at how the everyday foods you just, toss in your grocery cart can literally hack your biology to naturally boost this gas.
Because it's really about taking control of that biological system.
So let's unpack this, because before we can even talk about the produce aisle, we have to understand why the medical community completely lost its mind over this gas back in the 90s.
Oh, they absolutely did. So the molecule is nitric oxide, or NO. And to really grasp why it won the 1998 Nobel Prize in Medicine, you kind of have to understand how scientists used to think the body communicated.
Like before the discovery.
Exactly. Up until then, we thought cellular signals had to be these really complex, heavy proteins.
Things with actual mass.
Right, things that fit perfectly into specific cellular receptors, almost like a literal physical key going into a physical lock.
So something with structure and permanence, not a fleeting gas.
Yeah, exactly. The idea that a simple, highly reactive, and, nearly invisible gas could act as a master signaling molecule.
It was probably crazy, dog.
It's considered absolute heresy. But that is exactly what nitric oxide does. It's an endothelial-derived relaxing factor.
Endothelial-derived, so it's made in the blood vessels.
Yes, produced right there in the endothelium, which is that ultra-thin inner lining of your blood vessels.
Okay.
And as soon as it's created, it just permeates right into the smooth muscle cells surrounding the vessel and literally commands them to relax.
And just doing the basic math on that, when those inner muscles relax, the blood vessel widens, right?
Exactly. The pipes open up.
The pipes open up. Blood flows much more freely, and your blood pressure just plummets.
It plummets. But, and here's the massive caveat, because nitric oxide is a highly reactive free radical itself, it is incredibly unstable.
How unstable are we talking?
We are talking about a lifespan of mere milliseconds.
Wow.
Yeah, milliseconds before it degrades or just reacts with something else in the bloodstream.
Milliseconds. I mean, that is a desperately short window to get anything done.
It's basically instantaneous.
It means you can't just synthesize a big batch of this stuff on a Sunday and let it ride for the rest of the week.
Not at all. Your body is forced to manufacture nitric oxide continuously, like on demand, right at the exact microlocation where it's needed.
That sounds exhausting for the body.
Well, if you want optimal health and you want to prevent age-related vascular decline, you have to maintain a steady, unyielding supply of the raw materials to build this gas.
Which brings us to the real plot twist in the article. Because the human body, in all its crazy complexity, doesn't just have one way to make this life-saving gas.
No, it has two completely distinct pathways.
And understanding the difference between those two pathways is basically the entire key to why your diet becomes so staggeringly important as you age.
Absolutely. So let's look at the primary pathway first. This is the main engine for a young, healthy body.
Oh.
It relies on an internal enzyme called nitric oxide synthase, or nNOS.
nNOS, like the stuff they put in race cars.
Yeah, similar acronym, but completely different biology.
Right.
This nNOS enzyme acts like an internal factory. It takes an amino acid circulating in your body called L-arginine, heavily oxidizes it.
Meaning it uses oxygen.
Exactly. It requires a massive amount of oxygen to do this, and the result is nitric oxide. When you're 20 years old, this factory runs flawlessly.
But biology has a timeline. The My Whole Foods piece makes it very clear that this state-of-the-art internal factory inevitably starts to rust.
It does. Over the decades, you get oxidative stress and just general cellular wear and tear.
And that causes the INAS enzyme to become sluggish.
Yeah, the machinery just breaks down, and suddenly your internal factory is completely failing to meet your daily quota for vasodilation.
So your blood vessels can't relax.
Right. That specific decline in factory production is a massive underlying cause of age-related hypertension.
Wow.
Yeah, when the gas drops, the vessels stiffen, the heart has to pump much harder.
But the human body has a contingency plan, thank goodness.
It does.
Because we can't easily fix the rusting factory, right? We have to rely on a secondary system. The article calls it the nitric oxide pathway.
What's fascinating here is how the body shifts its reliance to external sources. This secondary pathway is essentially a dietary backup generator.
A backup generator, I like that.
And what makes it so incredibly vital is that it operates completely independently of that failing NOS enzyme.
So it doesn't need the broken machinery.
Exactly. It doesn't need L-arginine, and even more critically, it doesn't need high levels of oxygen.
Oh, really?
Yeah, it can function perfectly in hypoxic or low oxygen environments where the primary factory would just shut down entirely.
But here is the catch for you listening. That backup generator requires fuel that your body cannot make on its own.
Not even a little bit.
It relies 100% on dietary inorganic nitrates, which means to keep the backup generator running, you are entirely dependent on what you choose to put on your dinner plate.
It literally transforms food from just, generic fuel for energy into a very direct, non-negotiable chemical supply chain.
You need the specific compounds found in whole vegetables.
Or your blood vessels will literally lose their elasticity.
Now, I need to stop you here because the journey of how a spinach leaf actually gets turned into a blood pressure-lowering gas inside your body is honestly one of the strangest things I've ever read.
It's a very bizarre detour, I'll give you that.
It feels almost like a design flaw, but it's brilliant.
Yeah.
Walk us through this saliva symbiosis.
It is a marvel of symbiosis.
Yeah.
So you eat a nitrate-rich food, say a bowl of Swiss chard.
Okay, eating my chart.
You digest it, and the nitrates move into your stomach and small intestine, where they're rapidly absorbed into your bloodstream.
Makes sense so far.
But instead of just using them right away, your body actively pulls up to 25% of those circulating nitrates out of your blood and pumps them back up into your salivary glands.
Hold on. It actively removes them from the blood just to push them into your spit.
Yes.
Why would it waste the energy to send them back up to the mouth?
Because your human cells actually lack the specific enzyme required to process those nitrates any further.
Wait, really? We literally don't have the enzyme.
We literally do not have the genetic coding to take the next step. We have to outsource the job.
That is wild.
So you secrete this highly concentrated nitrate-loaded saliva into your mouth. Waiting there, specifically nestled deep in the oxygen-deprived crypts on the very back of your tongue, are thick colonies of commensal anaerobic bacteria.
These are microscopic bugs that we just let live in our mouths.
Yes, and they aren't just hitching a ride, they are working.
Okay.
These bacteria use the nitrate from your food as a substitute for oxygen. They basically breathe the nitrate to generate their own cellular energy.
They breathe it.
Yeah. And in doing so, they rip an oxygen atom off the nitrate molecule. And the byproduct they leave behind, their metabolic waste, is a completely new compound.
Okay, wait. Let me get the terminology right, because the article is very specific about this.
Yeah.
The bacteria take the nitrate with an A and turn it into nitrate with an I.
Yes.
Do I have that right? Because they sound completely identical when you say them out loud.
You have it exactly right. Nitrate becomes nitrate. That's a chemical reduction.
Okay, got it.
Then, the next time you swallow, you are swallowing your own saliva, which is now heavily spiked with these vital nitrates.
Down the hatch.
Right. When that nitrate hits the highly acidic environment of your stomach and then mixes with specific enzymes in your blood, the final conversion triggers.
And that's when it happens.
That's when the nitrate is reduced down into active nitric oxide gas.
So if I'm understanding this correctly, if you don't have those exact bacteria hanging out on the back of your tongue, this entire life-saving biological chain reaction just hits a brick wall.
It completely halts.
The backup generator runs completely out of fuel, regardless of how many salads you eat.
Without the bacteria, the nitrate just circulates and eventually gets excreted. You get absolutely none of the vascular benefits.
Which leads directly to the most shocking part of this entire deep dive, the mouthwash mistake.
Oh, this is a huge issue.
Wait, so you're telling me that by trying to be perfectly hygienic and using antibacterial mouthwash, You are actively sabotaging your own cardiovascular system.
The clinical data strongly supports exactly that. The problem with commercial antibacterial mouthwashes is that they do not discriminate.
They just kill everything.
Right. They're designed to obliterate the bacteria that cause plaque and gingivitis, but in the process, they basically carpet bomb the entire oral microbiome.
So the good guys die too.
Exactly. They completely wipe out those crucial anaerobic bacteria on the back of the tongue.
That is staggering to me. You think you're doing the right thing. You're hypersterilizing your mouth to avoid a cavity, and as a direct result, you are stiffening your arteries.
It's a severe unintended consequence.
The article even cited clinical studies showing that regular use of antibacterial mouthwash can induce a significant, measurable spike in resting blood pressure within just a few days of use.
Because the moment those oral bacteria die, your body instantly loses access to that secondary nitric oxide pathway.
Wow.
It is a profound reminder that we are not isolated, sterile entities. We're massive, walking ecosystems, and hypersterility can severely disrupt fundamental health.
The article also mentions a highly mechanical requirement for this whole process, which is just chewing.
Yes, mastication is key.
You can't just throw a handful of spinach into a blender, gulp it down in 3 seconds, and expect the bacteria to do their job right.
Right. The physical act of thoroughly chewing your food is what mixes the dietary nitrates with your saliva.
Giving them time to mix.
Exactly. It gives those oral bacteria the necessary surface area and the time to actually begin that crucial conversion process.
Okay, so chew your greens, protect your mouth bugs. Let's get practical here. Now that we know how this bizarre machinery works, what are the absolute best foods we should be focusing on to feed this system?
Well, if you dive into the research, beetroot is the undisputed heavyweight champion of the dietary nitrate world.
Go beets.
Yeah, its deep red roots contain a concentration of inorganic nitrates that is very hard to rival.
Gregory David points out in the article that drinking concentrated beetroot juice can drop systolic blood pressure by 4 to 5 millimeters of mercury in a matter of hours.
It's remarkably potent.
That kind of physiological response is comparable to some prescription blood pressure medications, just from a root vegetable.
It really is, and continuously consuming it doesn't just cause a temporary drop.
What else does it do?
It actively helps maintain the structural elasticity of the arterial walls. So it's preventing the long-term stiffening that leads to severe cardiovascular events.
But while beetroot hogs the spotlight, I think the dark leafy greens are the actual unsung heroes here.
I completely agree with you.
Let's talk about arugula, because I always assumed spinach was the king of the greens, but the article completely changed my mind on arugula.
Many people are entirely unaware that arugula, which is often called rocket in other parts of the world, actually contains significantly more nitrates by weight than beetroot.
Wait, really? More than beets?
Yes, substantially more.
That's crazy.
Spinach, Swiss chard, and kale are also incredibly dense in nitrates, and there's a massive biological advantage to consuming a large, diverse salad with a mix of these dark greens over just taking a shot of beet juice.
Because of the fiber.
Exactly. Eating the whole leaf provides a robust, complex matrix of dietary fiber.
Right, the fiber slows down the digestion process.
Precisely. Instead of flooding your system with nitrates all at once, the fiber ensures a slow, methodical release into your bloodstream.
So it lasts longer.
Yes. It provides your body with a steady, all-day trickle of nitric oxide precursors, which is much more effective for long-term vascular tone.
But wait, if nitric oxide is as fragile as we established earlier, if it degrades in mere milliseconds,
Yeah.
how does it survive long enough to do anything?
Ah, that is the million-dollar question.
The article emphasizes a very specific synergy required to keep the gas alive, involving vitamin C.
This is a crucial piece of the puzzle. Because nitric oxide is a highly unstable free radical, it's immediately targeted by other oxidative free radicals in your bloodstream.
They just attack it,
They will react with it and neutralize it almost instantly.
so you lose it.
Right. If you want to actually keep the NO gas around long enough to reach your blood vessels, you have to pair those plant-based nitrates with potent antioxidants, specifically vitamin C.
I love the practical example the My Whole Foods article gives for this. It suggests making a spinach salad topped with sliced strawberries and a lemon vinaigrette.
It sounds delicious, but it's also highly functional.
I look at it this way. The spinach provides the raw nitrate fuel, but the strawberries and lemon provide the vitamin C, which acts like a molecular bodyguard.
Molecular bodyguard is the perfect way to visualize it.
The vitamin C essentially flanks the fragile nitric oxide gas, and it willingly absorbs the attacks from other free radicals.
Taking the hit.
Yeah, by taking the hit, the bodyguard safely escorts the NO through the bloodstream, dramatically extending its lifespan so it can actually reach the vascular walls.
If we connect this to the bigger picture, your bodyguard analogy beautifully explains why extracting nutrients into isolated supplements is so often ineffective.
Because they're alone.
Exactly. A synthetic nitrate powder might give you the raw chemical, but it entirely strips away the vitamin C, the polyphenols, the
Our
fiber.
bodyguards.
Right, the very bodyguards that the molecule absolutely requires to survive the hostile environment of the human bloodstream.
Okay, but this brings up a massive contradiction, and honestly, you're losing me a bit here.
Oh, how so?
You've just spent 10 minutes telling me that nitrates and nitrites are literal medicine, that they are essential for keeping our arteries young.
Yes, they are.
But my entire life, I have been warned that the nitrites in bacon, hot dogs, and deli meats are toxic and cause cancer.
Ugh, yes, the bacon dilemma.
It is the exact same chemical compound. How does the human body know whether I just ate a spinach leaf or a slice of salami? Does the biology just magically change?
This is perhaps the most heavily misunderstood concept in all of nutrition, and it entirely comes down to the packaging.
The packaging of the food.
Yes. There is a hard biological line between the inorganic nitrates naturally found in a plant matrix and the synthetic nitrites added to ultra-processed meats.
So to be clear, it's not the nitrate molecule itself that's the villain, it's the packaging. The exact same compound that heals your heart in a plant will harm you in a hot dog because it lacks the protective antioxidant matrix.
Exactly. Let's look at the chemistry. When you consume nitrates in a whole plant, like your spinach and strawberry salad, they coexist with that vast matrix of antioxidants and vitamin C.
The bodyguards.
Right. When the nitrite hits the highly acidic environment of your stomach, those antioxidants actively block the nitrite from binding with other amino acids.
So they protect it.
They force the nitrite to convert safely into beneficial nitric oxide.
But in processed meats, there are no bodyguards.
Precisely. Manufacturers inject synthetic nitrites into deli meat purely as a preservative and, to give it that appealing pink color.
Right.
Those synthetic versions completely lack protective antioxidant compounds. And to make matters vastly worse, meats like bacon are usually exposed to incredibly high cooking temperatures in a frying pan.
Oh, so the heat changes the chemical reaction.
Yes. When you combine isolated synthetic nitrites, high heat, the specific proteins in meat, and a total lack of antioxidants, a completely different chemical reaction occurs.
What happens?
The nitrates rapidly bind with amines in the meat to form highly potent, incredibly dangerous compounds called nitrosamines.
Nitrosamines.
And nitrosamines are notoriously carcinogenic.
Okay, that is a light bulb moment.
Okay.
It's the exact same starting molecule, but because we stripped away its natural plant context, its bodyguards, and blasted it with a frying pan, we forced it down a completely different toxic chemical pathway.
You're completely altering its fate.
It really proves that you cannot outsmart the biological matrix. You can't just rip a chemical out of a leaf, throw it into a hot dog, and expect your body to handle it the same way.
You really cannot. If you want the vasodilation without the cellular damage, you must strictly rely on the complex packaging found only in fresh, whole fruits and vegetables.
Okay, we've completely decoded the chemistry. We know what to eat, we know what to avoid. Let's transition into actionable strategy.
Let's do it.
Because the My Whole Foods article makes it clear that the applications here aren't just for preventing disease when you're older. They are for actively improving your daily physical performance right now.
Absolutely. From a purely clinical standpoint,
Right.
keeping your nitric oxide levels high stops endothelial dysfunction in its tracks.
Keeping the arteries flexible.
Right, keeping them flexible and preventing plaque buildup. But the immediate day-to-day performance benefits are what usually catch people's attention.
The sports nutrition angle.
Yes.
The article talks about elite endurance athletes, cyclists, marathon runners, Olympic swimmers, using a protocol called beetroot juice loading before major competitions.
It's incredibly popular in elite sports.
The surge in NO dilates their vessels, rushing massive amounts of oxygen and nutrient-dense blood straight to their skeletal muscles.
A true physiological hack of why they don't fatigue as quickly goes even deeper than simply widen blood vessels. Nitric oxide actually alters the efficiency of your mitochondria.
The powerhouses of the cell.
Exactly. Inside your mitochondria is something called the electron transport chain, which is how your cells generate energy.
Okay.
Often, this chain is slightly leaky, meaning it wastes some of the oxygen you breathe in. Nitric oxide essentially plugs those leaks.
It plugs the
It
leaks.
optimizes the entire chain. The clinical result is that it literally reduces the oxygen cost of exercise.
Here's where it gets really interesting, reducing the oxygen cost. That means your muscles literally require less oxygen to produce the exact same amount of mechanical power.
Think about the profound advantage of that.
It's massive.
If the oxygen cost is lower, you can maintain a much higher intensity of physical work, but your perceived exertion plummets.
You just don't feel tired.
You simply don't feel like you are working as hard because your cellular engines are suddenly running with zero waste.
You can literally run just as fast, or push through a grueling workout, or even just climb a steep flight of stairs and find yourself breathing significantly less hard. And all purely because you ate an arugula and beet salad a few hours ago.
It feels like a cheat code, doesn't it?
It feels like cheating biology.
It's just tapping into an alternative energy pathway. And the timing of when you eat these foods is critical if you want to capture that specific mitochondrial peak.
Right, because of that weird saliva detour. It takes time for the blood to send the nitrates to the mouth, for the bacteria to chew on them, and for you to swallow them back down.
Exactly. The clinical literature shows that the peak concentration of nitric oxide in your bloodstream hits roughly 2 to 3 hours after you consume the plant nitrates.
Okay, 2 to 3 hours.
So, if you are prepping for a marathon or even just a heavy gym session, you need to consume your beets or dark greens about 120 to 180 minutes prior to the event.
But what if I'm not running a marathon? What if I just want all-day cardiovascular maintenance and steady energy at the office?
Then you want to divide your intake to keep the backup generator constantly fueled.
Spread it out.
A fantastic strategy is a nitrate-rich smoothie in the morning and a large, dark, leafy green salad in the evening. This ensures your vascular endothelium is continuously bathed in the restorative effects of the gas.
That makes sense.
And a quick note on that morning drink, blending whole beets and greens into a smoothie is vastly superior to using a cold-pressed juicer.
Oh, because the juicer strips out all that fiber we were talking about earlier.
Exactly. Blending retains the vital dietary fiber matrix.
Keeping the slow release.
Not only does this feed your gut microbiome, but it violently slows down the absorption of the natural sugars found in the beets, preventing a glucose spike while ensuring that slow, steady trickle of nitrates.
So what does this all mean? We've covered a tremendous amount of ground today.
We really have.
For you listening, we started with gas so seemingly impossible that discovering its function won a Nobel Prize.
A literal puff of gas.
We learned that while our youthful internal factories for making this gas inevitably rust and slow down, we are gifted with a brilliant dietary backup generator.
Our secondary pathway.
Exactly. By consuming whole plant-based nitrates like arugula, spinach, and beetroot, and critically, pairing them with the vitamin C molecular bodyguards, we can entirely bypass age-related vascular decline.
Which is incredibly empowering.
It really is. We navigated the bizarre detour to the back of our tongue, proving exactly why we must chew our food thoroughly and absolutely ditch the hyper-sterilizing mouthwashes.
Save the bugs.
Save the bugs. And we unpacked the profound difference between a healing plant matrix and a toxic, heat-blasted processed meat.
This raises an important question, though. How many millions of people right now are suffering from unexplained chronic fatigue, heavy limbs, or steadily climbing blood pressure simply because they aren't providing their body with the specific fuel required to utilize this alternative pathway?
Probably a lot of people.
We hold the power to fundamentally transform the elasticity of our arteries and our cellular stamina using nothing more complex than the produce aisle.
It truly is profound,
Right.
life-saving medicine hiding right there in plain sight.
It is. But if you step back and look at the absolute fragility of this system, it leaves you with a deeply unsettling thought.
What's that?
We learned today that simply using antibacterial mouthwash can inadvertently destroy the crucial bacteria that regulate our blood pressure.
Right.
It makes you wonder, what other microscopic, invisible ecosystems are we unknowingly wiping out in our modern quest for hypersterility? What other unseen microbial allies are living on you right now, just waiting for the right foods to do their job?